Hi everyone. For this video we're going to be looking at definition of a limit. And so let's get right into it. Let's talk about what a limit is. So a limit is the y value a function approaches. Sorry, my handwriting is not the greatest on this. From both the left and right side given a specific x value. So essentially a way to think about this is a limit is really looking at the behavior or the y values, what's happening to the y values as I get closer and closer to a specific x value. All right, and so let's take a look at some examples here. And it's really important to pay attention to notation. So if I look at this first example, remember this notation you should know already. That is saying f of -3. So what is the y value when x is -3? And so if I go where x is -3, I see that it's up here, and the y value that corresponds to that is 4. Now, the limit is something a little different, okay? So limit is saying, what are the y values look like as you approach -3 from both the left and right side? So again, we're still looking at what happens as I get closer and closer to that red dot there, but we're looking at what it's approaching. So if I look on the left side here and I follow the graph up, right? So as I follow the graph, I can see that it's approaching the same value 4. And if I'm looking from the right side, it's the same thing. I'm going to see as I move closer and closer to x equals -3, I can see that it's still approaching the same value of 4. Now that may seem a little confusing, and this is why we've got a lot of examples here. So if I look at the second example, again, we're going to be looking at what does it mean, f of -3. So at -3, what is the y value? Now, -3, x equals -3, is here on the graph, but as you can see, that's an open circle. So because it's open, it actually does not exist there. Okay, that's not over here in the first example, there was no open circle there. It was a part of the function. But here there's an open circle, so it does not exist. D-N-E, that's an N. And now we're going to do the same thing. We're going to look and see what happens as we get closer and closer. All right, so if I'm looking on the left-hand side, same thing. I'm going to, as I approach x equals -3, where is it trying to get to? And it looks like it's trying to get to 4, a y value of 4, right? And same thing with the right-hand side. As I approach it from the right-hand side, it's still trying to get to 4. So notice, even though the point does not exist there, the limit still exists because we're looking for, what it's trying to approach coming from the left and right side. All right, let's try the third example here. So f of -3. So again, what is the y value when x is -3? So if I look at this graph here, I can see that it is defined here, right? There is a solid point there. This point up here is open, so it's not defined there, right? And so we're really looking at where that solid point is, and what's the y value at that point? It's a 1. All right, now we're going to look at the limit again. So as I approach -3 from the left and right side, so let's start on the left. As I approach x equals -3 from the left side, notice it's still going to 4. It's still trying to get to 4, a y value of 4. As I approach from the right side, it's still also trying to approach a value of 4, so the limit is still 4. So even though it's not defined there, the limit is still defined to be, or still approaching 4. All right, let's take a look at the next example, f of -3. So where is f of -3? Well, I see a solid circle here, and the y value there is 1. So remember, we're not going to look at this one because that's an open circle. All right, and then let's look at the limit. So as I approach -3 from the left side and from the right side. So from the left side, here I am. From the left side, it looks like it's approaching a y value of 4, right? Okay, so from the left side, it's approaching 4. Now let's look and see what happens from the right side. Well, from the right side, if I follow this, right, it looks like it's approaching a y value of 1. So from the left side it's approaching 4, from the right side it's approaching 1. Now notice they are not approaching the same value from both sides. And so when that happens, we say that the limit does not exist. So it exists when they approach the same value, okay, from the left and right side. And then the last example here, so f of negative 3, I see there is a closed circle there, so f of negative 3 is 2. And now if I look at the limit as x approaches negative 3, let's look from the left side. So from the left side, it's approaching a y value of 4. From the right side, it's approaching a y value of 1. So notice they are not approaching the same value from either side, so again, the limit does not exist. All right, so we've been looking at how to find the limit from both the left and right side, and so that kind of leads us to the next thing here, is what we call one-sided limit. So a one-sided limit is the y value. So again, where is it approaching? A function approaches as you approach a given x value from either the left or right side. Okay, so notice when I was doing these examples up here, I kept saying, you know, what's happening from the left and what's happening from the right. We're going to be doing the same thing here, but we're going to talk about notation a little bit first. All right, so if I'm looking at this graph here, and this first example, all right, it says the limit as x approaches 3, and then you see this little negative sign there. That little negative sign is indicating which direction you are coming from. So because I see that negative sign there, this is saying I'm approaching 3, so here's where x is 3, but because of that negative, it's saying from the left side. So I am, if I'm looking at this function, I'm coming down this way. I'm getting closer and closer to 3 from the left side. And so when we read it, the way we read it, you can see over here, we say the limit of f as x approaches 3 from the left side is, and we can see as we approach from the left side, right, we're trying to get to a y value here, which is negative 1. Okay, so from the left side, the limit as x approaches 3 is negative 1. So now let's take a look at what's happening from the other side. So when you see a little plus sign, that's indicating from the right side. So again, I'm going to see what happens as I approach 3 from the right side. So now I'm looking at this piece, right? So coming from the right, where is the function trying to get to? So if I'm coming down here, I can see it's approaching here, right? And so what y value does that correspond to? 2. So the way we say it is the limit of f as x approaches 3 from the right side is 2. All right, and so the reason why we do this is because as you can see from above, the limit may not exist, or the left side and the right side may approach different y values, so it's important to be able to understand this notation. So let's just do a few examples. So here's our graph, and let's try to see if we can compute all of these here. All right, so let's look at the first one here. It says we're going to find the limit as x approaches negative 2 of f of x, and this is the function f of x. Now I see that little minus sign, so I'm coming from the left, okay? So here's where x is negative 2, and if I approach it from the left side, so I'm coming from this side, what value is it trying to get to? Well, if I keep going here, it's trying to get to a value of 1. So this is equal to 1. All right, now we're going to do the same thing. We're going to approach negative 2, but now we're going to approach it from the right side. All right, so now I'm looking at this function here. So here's negative 2, right? Now if we're coming from the right, so coming down this way, what y value is it approaching? Well, it looks like it's approaching negative 2. Because I kind of covered it up here, but looks like this value corresponds to negative 2. Okay, well, now if you look at this notation here, it says the limit as x approaches negative 2. Notice there's no plus or minus sign anywhere, and that is because when you don't see that, you need to look at what's happening from both sides. just like we did on the first page. All right, well, we already know from the left side it's 1, from the right side it's -2. Now, the problem is they're not approaching the same y value, and so because they're not approaching the same y value, we say does not exist. Okay, so the overall limit does not exist, even though the left side does and the right side does. It's just the overall, they don't go to the same value. All right, so let's try some more here. Find the limit as x approaches 1. Notice there's no plus or minus there, so I am going to look at where x is 1, so here it is, and because there's no indication of which side I'm coming from, it's assumed that you're checking from both sides. So if I come from the left and if I come from the right, notice they approach the same value, which is 1. All right, we're going to do the same thing for the limit as x approaches 0. So where x approaches 0, okay, so it's really right here. What's happening there? Well, if I approach it from the left and I approach it from the right, do they go to the same y value? And they do. Looks like -2. All right, let's see, 11, or not 11, oh gosh. Limit as x approaches 3 from the left. So now let's find where x is 3. So we're here, which means we're looking right here. Now it's just asking specifically from the left side. So as I come up, what y value is it approaching? And it looks like it's approaching 5. All right, limit as x approaches -1. So where's -1? Here it is. So we're really looking at this point here on the graph. And there's no plus or minus there, so we're looking at the overall limit. So as you approach it from the left and from the right, so from the left side, from the right side, it is going to the same y value, which is -3. And then this last limit one says as x approaches -3, so let's find -3, which is right here. What is the limit? So let's look at it from the left side and the right side. What y value is it approaching? And it's a y value of 0. Okay? And then the last two are just where is it defined? So like it says f of 1. So when x is 1, what is the y value? So here's when x is 1. Well, notice there's an open circle here, so I'm not going to use that one. There's a closed circle here, so that means it's defined there. And so the y value is -2. And then if I look at f of -2, where is it defined? I go to where I see a closed circle, and so it equals 1. So make sure you understand how to find those graphically. And the next part we're going to talk about is when does a limit not exist? So there are cases when the limit doesn't exist, and we've looked at a couple examples already. The first one that we looked at is that if the left, oh gosh, my writing is awful. Let me try that again. If the left side and the right side, now this isn't completely math notation here, but since I write so big on this screen, basically if the left side limit does not equal the right side limit, then that's the limit, overall limit doesn't exist. There's another example which is called Unbounded Behavior. So an example of that is like a vertical asymptote. So if I have a vertical asymptote, right, we could have limits going forever, like to infinity, for example. And then the third one, which we won't be seeing a lot of yet, is what we call oscillating behavior. And what that means is basically the function kind of moves back and forth around a particular value. Right, so when we think of oscillating, we kind of think of something like this. It hovers around a particular value. Okay, so we've already seen examples of number 1. We're going to see more examples of number 2 in future notes. And we'll probably see a couple here and there of number 3, but it's not something as that we focus a lot on. All right, so it also says we can also estimate limits using tabulated values of a function. And so that's what we're going to do next. And it kind of relates back to the rates of change notes that we looked at before. So let's take a look at an example so you can see what we mean by that. All right, so it says create a table of values of f of x is equal to, here's your function, corresponding to values of x near 1. Now, if you're wondering why we're looking at 1, is because if I were to plug 1 in, I would have 1 minus 1, which is 0. And if you can't have 0 in the denominator, right? It doesn't exist there. So we're going to see, we're making a conjecture of what's happening. And yes, you could graph it, of course, and look at it. But because it says create a table, that's what we're going to do. We're going to actually create a table here. And so I'm going to have a table of x and f of x, okay? And what I'm going to do is again, just like kind of like what we did with rates of change with the average velocities, I'm trying to see what happens as I get closer and closer to 1 from the left side and from the right side. Okay, so from the left side and from the right side, what's happening? What's happening to those y values? So I would have you pause the video, try some values yourself, and then when you come back, I am going to show you what I have on my chart. But pause the video, try it yourself, and see what kind of values you think is happening. Okay, welcome back. Like I said, hopefully you have some of your own values. They don't have to be the same as mine. As you can see, I started kind of a little far away from 0, or far away from 1. I started with 0. But as you can see, I chose values a little bit closer and closer to see what would happen. And so if I look at what's happening from this side, from the left side of 1, it kind of looks like that it's getting closer and closer to 0.5, right? So notice 0.586, 0.536, and so on. And the same thing with this side. So if I approach 1 from the right-hand side, as I get closer and closer to 1, notice that these values are also approaching 0.5. So from this, I'm going to make the conjecture that the limits as x approaches 1 of this function is really 0.5. So we can have a table of values that can help us kind of figure out what the limit is.